Welcome to Project 5 of the SparkFun Inventors Kit with MicroPython, Robotics. In this circuit, we'll introduce 3 new components: a switch, a motor driver, and a DC gear motor. Remember from our discussion on buttons that a switch is a component that controls whether a circuit is opened or closed. However, unlike our push buttons, which are only closed while they are actively being pressed, the 3-leg switches we'll use in this circuit maintain their state of opened or closed until their position is switched. This makes them well suited for on-off switches. Our switch has 3 legs and 2 possible positions. In one position, legs 1 and 2 are connected. In the other position, legs 2 and 3 are connected. We'll connect leg 1 to a digital input so we can measure whether the switch is switched. We'll connect leg 2 to ground. So, in the first position of our switch, when legs 1 and 2 are connected, our input will be connected to ground and will read low. We'll use this as the on position. We'll leave leg 3 unconnected to anything. So when the switch is in the second position and legs 2 and 3 are connected, we need a way to guarantee that our pin always reads high. To do this, we'll use the built-in pull-up resistor that we can enable with code, just like we did for the buttons in Project 2. The motors we're using in this circuit are very different from the servo motor we used in Project 3. They are DC gear motors. Inside these motors are coils of wire that generate magnetic fields when a current flows through them. When power is supplied to these electromagnets, they spin the drive shaft of the motor. The motors also contain a gearbox, which gears down the rotation of the motor, making it slower but stronger, allowing it to move our heavy robot. We want to control 2 motors, and we want to be able to easily change their direction and speed. That's where our motor driver comes in. To change the direction that our motors spin, we change which of their leads is connected to a high voltage and which is connected to a low voltage. Our motor driver allows us to accomplish this easily by having 2 inputs for each motor, AN1 and AN2 for our first motor, and BN1 and BN2 for our second motor. For each motor, setting IN1 high and IN2 low will spin the motor forward, and setting IN1 low and IN2 high will spin the motor backwards. To change the speed of the motors, the motor driver has a PWM pin for each, PWM-A and PWM-B. By providing a higher duty cycle PWM signal to PWM-A, we will spin the first motor faster, and likewise for PWM-B and the second motor. The motor driver board has a clever chip on it that will take in all of these inputs and give us the correct output for each motor on A-out1, A-out2, B-out1, and B-out2. That's about it for theory on Circuit 5A. Now let's build the thing. For this circuit, we'll start with only a single motor. We'll make the connections for each of motor A's inputs. We'll do the same for motor B, even though we're not using it, to give us a head start for next circuit. Then we'll connect the A01 and A02 outputs to motor A and connect all the necessary power and ground connections for the driver. We'll also connect the switch in the configuration that we discussed before. Now let's scroll down and see some code. Our first cell will set up our pins for all of the motor A inputs and the switch with its pull-up resistor. Next, we'll run the second cell to set up the functions for spinning the motor. This function sets up all of the necessary inputs for our motor and can be provided a negative speed to drive backwards. Finally, we can run the last cell, and our motor spins if the switch is in the correct position. Feel free to mess around with the speed variable to make your motor faster or slower. That's all for Circuit 5A, Motor Basics. We've just learned some foundations that we're going to put to work in Circuit 5B, where we'll build a remote-controlled robot.